This meeting is being recorded.
In this next section, we're going to take a look at when aereo isn't the clear-cut or deciding factor for pKa determination or determining which acid is stronger than another. So most of the time, this can be used as our explanation, but at times we'll see things like solvating effects that can actually contribute to differences in, slight differences usually, in pKa values. So we have a similar structure here in the sense that it has an alcohol functional group. So looking at these protons and their acidity, you might be shocked to know that ethanol and tert-butanol are about 2 pKa units difference in their acidity. So as always with acids, this acidity difference is due to the stability of the conjugate base. But at times, the solvent that helps to stabilize this conjugate base will be the deciding factor. So let's take a look at these solvating effects when sterics have to play here. So we have a tert-butoxide ion on this side, and then we have our ethoxide ion over here. So both of these species have been deprotonated, and notice that this tert-butoxide over here is what we call sterically hindered. So there's these groups here coming off of that central carbon, these methyl groups that block the solvent from reaching, certain parts of that molecule. So as an effect, tert-butanol would not be as acidic as ethanol, and that's because that proton is not as solvated because of the steric hindrance of these other groups, but the ethoxide is able to be more well solvated, and therefore ethanol would be about 2 units higher in acidity, or 2 units lower rather, of pKa. So this next section introduces us or reintroduces us to something called spectator ions, which you probably have seen in general chemistry when you did net ionic reactions. So these counter ions are just there to stabilize a charge. So here we have something called sodium amide, and a lot of times when you see reactions, these counter ions are not included because they don't actually react, they just spectate, right? Remember, spectator ions just kind of hang out, neutralize charges, and don't actually react. So what we see in this example down below is that the amide reacts with water, becomes ammonia, and hydroxide. So we know that there are actually sodium counter ions floating around, but they're not always shown in reactions.